What if we could predict how plants will react to environmental changes in the future? Because of our ever-changing climate, global temperatures are expected to rise by 5 degrees Celsius, and droughts are expected to increase in severity by the year 2100. If we knew how plants crucial to our agriculture and to our ecosystem performed under these increasingly harsh conditions, we can figure out how to combat the possible loss of ecosystem services, aka any benefit that wildlife or ecosystems provide to people. Climate change impacts these large-scale ecosystem services like air purification, carbon storage, erosion control, and agricultural security and diversity, and therefore negatively affects local trophic interactions. A lower soil moisture caused by drought, along with growing temperatures, increases foliar nitrogen levels, reduces concentrations of secondary metabolites, and causes host plants to grow more susceptible to herbivores. However, increased temperatures can also cause a loss in plant nutritional quality through a decline in sugar content, decreasing herbivory rates. By focusing on the joint effect of warming temperatures and increased drought on plant health and herbivorous interactions, we can explore past this contradiction and predict how well an ecosystem can function in the next 80 years. In order to explore this joint effect further, I grew 64 rough-stemmed goldenrods and 64 panicled asters in 16 garden beds at the Smithsonian Environmental Research Center in Edgewater, Maryland. Both of these species are host to over 100 local insect species, making them crucial herbaceous plants to the ecosystem. I hung heat lamps turned to 5 degrees Celsius to simulate global temperatures in the year 2100. For 5 weeks every Thursday, I measured soil moisture, plant height, leaf damage, insect abundance, and predator abundance. After the conclusion of the experiment, I harvested all of my plants and measured above and below ground biomass. While the goldenrod grew more overall, the height of both species increased with the warm treatment over the ambient treatment. There was no significant difference in biomass ratio, revealing that while the warm treatments grew taller, they did not grow more leaves or larger leaves. The goldenrods that grew taller in the warm treatment were likely being targeted more by insects because of their size, explaining the result of greater herbivory on warmed goldenrods than ambient ones. The asters were likely more damaged than the goldenrods because of their thin, less protected leaves. This adds to the point of different herbaceous species reacting in various ways to temperature and soil moisture treatments. Because crucial herbaceous species like goldenrod and aster will be affected negatively by these climate change factors, we must be prepared for our ecosystem services to change as well. We must be mindful about what we plant and the possible repercussions our future climate may have on them.